Go ahead.
So, it shows integrals and what their value equals. And so, when I thought of this first one, the first integral that it gives you, I put that equaling like capital F, or like the antiderivative of f of x, or f of 2 minus the antiderivative of f of 5 would equal 17.
Yeah, that's not a bad thought. Like, they don't say it in this problem, but there are lots of problems where they'll refer to capital F as being the antiderivative of small f.
Yeah.
So this would definitely be true.
Mm-hmm.
It's not so helpful in this problem because they don't give any indication as to what the heck, capital F is.
Yeah.
But that is true.
Yeah. And so then I kind of just started doing that to the next problem, and I saw the integral of 5 to 2, and I knew that 5 was greater than 2, and so something was probably wrong there. And I remember we went over a problem where you had to do something like take out a -1 or something, and so I couldn't remember the rule that was supposed to be applied, and so I was just stuck there.
Okay, so good memory. They give this integral, and the rule is that if this integral is going to equal -4, then if I switch the limits, like so, then the value of the integral changes sign,
Oh, okay.
like so.
Okay.
Now what you're remembering is a related, it's the same idea used in a different way. What we did previously is we had an integral like, say, from 5 to 2 of f, and we didn't know what that's going to equal. Like, we don't know. Okay? But we can say, oh, if I switch the limits, and then I multiply the integral by -1, I will get the exact same result.
Oh, okay.
So that's the exact same
The result
concept.
stays the same.
Yeah, same concept used in a different way.
Okay.
So here, because I know the result, the way I'm using the concept is I say, oh, let's switch the limits, that changes the result.
Okay.
If I don't know the result, I can be safe by saying, well, if I'm trying to find this, I can find it by either integrating backwards, which I don't want to do, or I can integrate forwards and just multiply by -1, and the results are exactly the same.
Okay.
Like if this is A, this is also A.
Yeah.
That makes sense?
Mm-hmm.
Keep going.
And so, well, I didn't really get to that part because I was just stuck with the negative, and so I kind of was lost about what to do from there.
Fair enough. Okay, this one is a problem you've never seen all year. It kind of falls in that category. I've never been able to find enough homework problems to give you to practice this idea. But it's an idea that shown once, everybody can do it. You just need help once.
Okay.
When I look at the problem, here's what I notice. I notice that the switching of the integral is key. So I'm going to definitely save that. Like I want to save this. I don't want to do a backwards integral.
Yeah.
I'm going to save that. I'm going to erase these others because as though they are valid comments, they're not really helping me. So the biggest thing I notice is that we have 3 integrals. All of them are integrating the same thing, f.
Yeah.
But then I notice the limits have an interesting pattern to them. Because they're asking me to find the integral from x equal 5 all the way to x equal +5.
Yeah. Which are the beginning and end.
Yep. So I remember a rule, which is this, which is pretty basic. We've actually used it before. We just don't, use it enough to really remember. You can break this integral into separate integrals. You can say, let's just integrate from -5, and let's stop at 2.
Oh, and then 2 to 5. So you could just add -17 and -4.
Yep, done. Yeah, that's why I say it's not that hard once you
Yeah.
have somebody show you. It just takes once to go, oh, I don't know why I didn't think of that, but
Yeah.
so I'm done. This integral is -17. This integral turned out to be +4. hence the correct answer is -13.
Yeah.
That's it.
Perfect.